Hello guys, welcome once more to Class Online. My name is Dami, and in this edition we shall be looking at Jamb Physics 2010 question number 36 to number 40. And this edition shall be super fun because we shall be dealing with key aspects of physics that many students find difficult, and we shall be simplifying it. Don't forget that if you learned something from this video, click on like button. We have a lot to share with you that will better help you understand physics. Now let's get to the question. Question number 36 says the diagram above shows a balanced meter bridge. The value of x is what? Now whenever you have a question on meter bridge, there is one super formula to use. Any question on meter bridge answers to this formula. Do you know what that formula is? And that formula is this. Now the formula is actually this formula. L over 100 minus L equals R1 over R2. But now the problem with this question is that it's not really a problem per se. It's just that this question, we have parallel connections here. Normally we should just have a series connection, that's one here and one here. But in this place we have parallel. So we have to make these two parallel to become series. And that is what I did. I summarize these two parallel first. And then so that I'm trying to make these two to become one. And because they are parallel connection and they are resistances, so I have to use the resistance formula for parallel, and that is 1 over R equals R 1 over 8 plus 1 over 8. That means the sum. I'm trying to find the total of these two, and if they are parallel and they are resistances, you need to use this formula to sum them up. 1 over R equals 1 over 8 plus 1 over 8, and that's 1 over R equals the LCM of 8 and 8 is 8, and that is 8 here. Then 8 divided 8 is 1. 1 times 1 is 1. 8 divided 8 is 1. 1 times 1 is 1. 1 plus 1 is 2 over 8. If you cut it down, I'll give you 1 over 4. 1 over R equals 1 over 4. So therefore, R, 1 cancel 1, R equals 4 ohm. So the summation of these 2 ohms, this 8 ohm and 8 ohm is 4 ohm. So I have 4 ohm here and I have 8 ohm here. So now that is balanced. That is the way it should be for me to use my meter bridge formula. So my meter bridge formula for any question on meter bridge is L over 100 minus L equals R1 over R2, right? That is the formula. Please take note. Now, what's my L? My L is my length. Now, from here, I can say that this is my length. The first length is X. That's this X here. So I call it L over, the second length is 100 minus L. That's 100 minus L. That's 100 minus X here. And it is just the same thing here. Equals the first resistance is 4. That's the one here. That's my total here. That's 4 ohm. Then the second resistance is my total here. That's 8 ohm. That's 8 here. And therefore, if I cross multiply, I'll be getting I cut 4 over 8. That will give me 1 over 2. So now I cross multiply. That will give me 100 minus L times 1. That is still 100 minus L. 2 times L, and that is 2L. Then this L will come from here to this side. That will give me 2L plus L. That's plus 1L. And that will give me 3L here. So 3L equals 100. Dividing by 3. And that will give me 33.3 centimeter as my length, my L. My L. That's my X. My X or my L is what? 33.3 centimeter. And that is the answer. Please don't forget the most important thing is the formula for meter bridge. L over 100 minus L equals R1 over R2, and that is just the way to go about it. So the answer is C. Number 37. 3 4 ohm resistors connected in parallel has a potential difference of 16 volts applied across them. What is the total current? First of all, show me parallel. Show me parallel connection for 3 4 ohm resistors. Now this is the parallel. 4 ohm, 4 ohm, 4 ohm. 3 4 ohms resistor in parallel. This is parallel connection. Okay, and this is the voltage here, 16 volts. Now, but first of all, we have to summarize this voltage because we have to find the total current, right? So summarize all these 3 resistors. You know, I told you we've learned that parallel connections are always using this formula: 1 over R equal 1 over each of them. 1 over 4 plus 1 over 4 plus 1 over 4. Right? Now the LCM here is 4, so 4 below. Right? 1 over R equals the LCM of 4 is 4. Then 4 divided 4 is 1. 1 times 1 is 1. 4 divided 4 is 1. 1 times 1 is 1. 4 divided 4 is 1. 1 times 4 is times 1 is 1. That becomes 1 plus 1 plus 1. That's 3 over 4. So therefore, the R total, that means the real R, is going to be the inversion of that. That because R equals 4 over 3. And that is the answer for your total resistance. But that's not the end of the road. But you have only summarized the 3-4 ohm resistance into one. And the final answer is what? 4 over 3 ohm, right? Now you have to find the current and you are given voltage and you found your resistance. When you see the word resistance, voltage, and current, that should remind you of one thing. That is Ohm's law. Only Ohm's law can define that. And this Ohm law, V equals IR. This is called Ohm's law. Okay? V equals IR. This is the summary of Ohm's law. Okay, now I'm to find current, right? So I'll make current the subject. I equals V over R. Okay, what's my V? My voltage given to me is 16 volts. 16 over what's my total R? I've summarized all the R, and this is my total 4 over 3. So if I'm to solve this one, this 3 below here will go up. That becomes 16 times 3 over 4. 16 times 3 and 4 divided 16 is 4. 4 times 3 is 12. And that is 12 ampere. And that is the answer. Or else you can just say 16 times 3 is 48 divided by 4 is 12. So it is 12 ampere. This is your total current. Remember, I summarized this resistors into using the word parallel law. And that gave me 4 over 3. Then I plug it into Ohm's law and I got my answer. V equals IR. I found my I. And that was what I did in this question. And that is a simple answer to the question. Number 38 says, so the number 37 answer is A. 38 says, in the diagram above, a 200 watt bulb is lighted by a 240 volt AC main supply. If 1 kilowatt hour is sold at 14 naira, the cost of keeping the bulb lighted for a day is what? Do you have any idea? Now, this topic is simply electric costing. It is super easy. Electric costing, I made a simple formula for that. Electric costing is simply power in kilowatt times time in hour times unit cost. Full stop. If you can plug this in, you get your answer straight up. For any question on electric costing, this formula will blast it. Now, power in kilowatt times time in hour times unit cost. And here is how to go about it. What is the power in the question? 200 watts, right? What is the time? 1 day is 24 hours. The time must be in hours. So 1 day means 24 hours. Then the unit cost is 40 naira. You were given 40 naira in the question as the charge. Okay, now but the power must be in kilowatt. The power here is in watt. So to make it, the first thing to do is to make it into kilowatt. That will become 200 watts divided by 1,000. Since 1,000 watts make 1 kilowatt. So you have to divide the watt by 1,000. That will give me 200 over 1,000 times 24 times 40. And that will give me 0.2 times 24 times 40. And that will give me 192 naira. That is a super easy answer. And that is just the end of the road. And that is for any question on electric costing, this formula will deal with it. And that is the answer to number 38. Number 38, therefore, is A, 192 naira. Number 39 says power supply is transmitted at high voltage and low current in order to work. Now, when power goes in high voltage and low current, what will happen? Does it increase the power supply, prevent overheating of the coil, make it travel faster, make it travel through the transformer? Do you have any idea? Now, the answer is super simple. Now, for heat, heat energy formula is IVT, and this formula has voltage and current, right? Now, but in the question we have low current and high voltage. That means that there will be minimum heat. I was the one who put this together. When one factor is going up and one factor is going down, and the last factor is constant, that means that it will neither be up nor down, it will neither be high nor low, it will just be minimum. That means the heat in this case will be minimum. It will be minimal heat, and that will prevent overheating. Because if it is too high, if the heat energy is too high, it might be overheating. If it's too low, it might not function. So to keep it minimal means to prevent overheating, and that is the answer. It prevents overheating of the coil. Super easy, right? Now number 46, in the diagram above, if the south pole of two magnets stroke a steel bar, the polarity at T and V will respectively be what? Now this is a magnet, right? You have south. When south is stroking, now this south is stroking towards V, and this air south is stroking towards T. What will be the polarity as T and V? Do you have any idea? Now there's one thing to know. The one thing to know is that if you are stroking, like this is my hand now, this is my hand, I just drew my hand. If you are stroking with the north pole of a magnet and you are stroking a metal, on the metal, if you are stroking with north, it will create south at that end towards which you are stroking. And at the opposite end, where you are not stroking, it will produce north on its own automatically. So if you are stroking one side of a magnet, at that side, if you are stroking with north, it will produce south at that side. That means opposite pole. Now, if you are stroking with south below, it will produce north on that side. Now, in the question here, we are stroking with what? With south. It will produce north here. If you are stroking with south also, it will produce the opposite pole, which is north here. So, because this is south and south, it will produce north and north at both ends. And that is the answer. So the answer will become north at both ends. Because you are stroking with south, it will produce opposite poles at both ends. And that is the answer for number 14. And that brings us to the end of this edition. Don't forget that if you learned something from this video, click on the like button. We have a lot to share with you that will better help you understand physics. But we see you guys. Take care of yourself and bye for now.